Hey everyone, welcome to the start of a new series. Now we are moving on in this series to some Year 10 content concerning mainly inequalities and linear relationships. The textbook that I'm working through here lumps in equations as well here, but all of the equations content is all revision from videos I've done in the previous years. So in this series, we are mainly focusing on inequalities as well as linear relationships. Now, we've touched on inequalities in the past, so this video is going to be just a little bit of a reminder, revision of what we mean by an inequality and how to solve different types of inequalities. Now, previously in the past, when we worked through solving equations, for example, so I don't know, 2x plus 1 equals 4. Now, this particular thing, we called it an equation because of this equality idea. The sense that the left-hand side is equal to the right-hand side. Now, what we look at, we switch gears when we talk about inequalities here. Inequalities represent something different. So if I, for example, write down a couple of inequalities here, so x is greater than 2 and x is less than or equal to negative 3, a half, x is less than 10. Okay, now these four signs are what we call inequalities. Now they communicate a bunch of different information here. Now this guy in the top left, this inequality, this means greater than. One number, x, is greater than 2. This thing here, you notice it's a similar looking thing, but it has this added line down the bottom here. Now, this is meant to resemble an equals. So if you look at an equal sign, it's got these two equal things here. So we write that extra line underneath our inequality to show that this is, now the sign is flipped compared to this one. So instead of being greater than, we are looking at less than or equal to. So we are looking at x, some number. This could be a number less than or equal to negative 3. This is the distinction between the two. Here, x is greater than 2. So it can't be 2 because it has to be bigger than 2. Here, it can be less than negative 3, or the value could also be negative 3. Moving right along, this one here, we have once again greater than or equal to, because we have that second line down the bottom. And here we have finally less than. And it's important here because to make this distinction between inequalities and equations, because when we looked at equations, we noticed that, well, the left-hand side is equal to the right-hand side. So I can just write this as this, for example. I can swap the order of terms. So the left-hand side is going to the right-hand side here, and the right-hand side is going to the left here. I've swapped the order, but because they're equal, these two things are communicating the exact same information. In the same way that, I don't know, 6 is equal to 6. Now, we can write that in another order with this number on the left-hand side, but it's just going to give us the exact same thing. When we're working with equal signs, the order in which we write these terms on the left-hand side or right-hand side of my sign here does not matter. Whereas perspective matters when we look at inequalities. Here, the inequality, it's telling us that the left-hand term this thing here is bigger than the thing on the right hand side. The order matters. This isn't like we can say, okay, well, x is greater than 2 and 2 is greater than x. It's like a contradiction. It doesn't really work like that logically. Now, in the same way, x here is smaller than or equal to -3, not the other way around. So the way we put this thing here, this inequality, where that goes, conveys certain bits of information. So the order in which we put this kind of matters. Now, what do all of these four things have in common? Well, they're all inequalities, I've said that already, but consider this inequality in the top left-hand corner. X is greater than 2. What could x be? Well, x could be any range of numbers. X could be 3, x could be 10, x could be 66, x could be 2.5. The solutions to x is going to be a lot of different ones, because my only requirement of this is that the number be greater than 2. So you can name off the top of your head like 20 different numbers that are greater than 2. So we're working with multiple solutions here. Same thing with this one on the top right hand corner. X is less than or equal to -3. This could be, a solution could be -3, for example, because -3 is equal to -3. So x here could be -3, it could be -10, it could be -27, it could be -1,000. There are a range of different answers here. And you can see that, hopefully, with these last two. You can take a moment to pause the video and try to think of a couple of values that x here and x here could be. But, excuse me, we're going to move on to look at how we can apply this and how we can actually visually represent this. And we're going to do so using the number line. So we're going to take this first inequality here, my x is greater than 2, and I want to visually convey this information. I have here x is greater than 2. And anytime we're dealing with numbers, we're going to draw up our nice little number line. And this extends infinitely in the left and the right hand directions. Now, I want to draw this up. Now, we said that x has to be greater than 2. So it's got to be all the numbers to the right of this 2 here on my number line. Because remember, we said it could be 3, it could be 6, it could be any number of numbers that are bigger than 2. And the way we show this is that I'm going to draw this circle. And now there's an important distinction that I'm going to make in a minute, but when we work with these particular inequalities, so just less than or greater than, I'm going to draw this open circle to show that it doesn't actually include this 2 here. And we're looking at every value bigger than 2. So every value to the right of this value of 2. So I'm communicating information here. My arrow is stretching infinitely into the, or to the positive side of 2. All the numbers greater than 2. So I draw my open circle to show that 2 is not included. And my arrow points to the direction of all the other numbers that satisfy this inequality. So in other words, all the values of x, all the possible values of x, which are greater than 2. Now let's look at another example. X is less than or equal to -3. So this guy up in the top right hand corner. I'm going to draw my number line again. Feel free to pause the video and have a go at doing this on your own if you're feeling comfortable. Okay, so what's different here? Well, now my inequality, it's all the values are less than -3, but this guy down here, this added line, tells me I'm looking at the values of x less than or equal to -3. So now I'm including negative 3 here. So instead of an open circle, I'm going to draw, instead of an open circle, I'm going to draw a closed circle. Think about when you plot a point on a line. So say you had your XY axis. If your point was, for example, 1, 2, you would do a closed dot to show that it has the value of 1 for X and the value of 2 for Y. These numbers are included here. Now, in the same way, for this particular inequality, my negative 3 is included. So I'm doing a closed circle. And my arrow has to point in the direction of all the values that satisfy this. So negative 7, for example, is less than negative 3. Negative 5 is less than negative 3. Negative 10, way over here, is going to be less than negative 3. So my arrow is going to point in this direction. Now let's look at one that's a little trickier. Our final example for plotting these on a number line is this guy here. And let's change this up. Okay. Now let's break this inequality because this looks slightly different to what we've been doing so far. Now, there are two kind of compounding bits of information that I'm being told here. One of these on the right hand side is that, well, my X is less than 0. So my X has to be a number that is less than 0. But on this right hand side, on this left hand side, so I've covered the right hand side, what about the information on this left hand side? Because we have now another condition. So my value of X, I have that negative 3 is less than or equal to my value of X. Or I can swap the order and I can say, well, minus 3 is less than or equal to X. I can also say that then X is greater than or equal to negative 3. And this notation up the top here basically consolidates these two ideas down the bottom and writes it in a nice compact way. So if we look at this linearly along a number line, what this is essentially telling us, these two bits of information, is that X is in between 0 and 3. But on these two ends, it's greater than or equal to negative 3 by this guy here. So I know it could be negative 3 or something bigger, but it is less than 0. So it can't be 0. It's got to be less than 0. And this inequality sign tells me that. So let's think of how we can actually write this information on a number line. This is when it gets a little bit trickier. So let's say 0 is here. -1, -2, -3, -4. Okay, let's look at the bits of information and try to apply this. Now, I want to look at my right hand side here first. So I want to draw something which is saying that X is less than 0. So we already know how to do that. I'm actually going to do this in a different color. So X does not include 0. So I'm going to draw a line stretching out from my 0 to the left hand side of my number plane. It's all the values that are less than 0, but not including 0. That's why I've done this open circle here. But another piece of information I'm given is this thing here, that X is greater than or equal to -3. So it could be equal to -3. So I'm going to draw this closed circle here. And it can be all the numbers that are greater than -3 in this direction. Okay, but it looks like we have some barriers happening here. Because on my left-hand side, I know that, okay, my arrow, it's going to be all the values that are less than 3. So I can consider all these values on this end of my number line. But I can't go too far because that would contradict this second inequality. So basically, we've got to stop right here. Because my value of x has to be, while also less than 0, it also must be greater than or equal to -3. So I'm going to disregard everything on this side of my number line. So I'm going to connect this here. But now my second inequality, I'm looking at all the values, all the values greater than or equal to -3, but I have to stop at a point because I can't exceed this value here. Because remember, x still needs to be less than 0. So I'm going to stop right here. Now, in other words, I've got the same line spanning from one to the other. So what I'm going to do, rub out these two lines and just draw one line joining these two values. Now, what this actually means is that all of my values that I can take have to be between these two points on my number line. And we can show that, and that's kind of why we draw it in this particular way, like we had up here, because I'm showing here, by writing it like this, that x lies in between 0 and -3. And the numbers I've shown here with my little purple line joining these are all the numbers between 0 and -3. I could be talking about, for example, -1 or -2 or -2.75 or -0.25. I'm showing a range of values here, and that's what inequalities represent, a range of different values. And the only thing we need to be really careful of is the way we draw our inequalities. Because I have a less than, or sorry, a greater than or equal to -3 here, I have to draw my closed dot, my closed circle. And because I have less than, so not less than or equal to 0, I draw my open dot here. But this is how we can work with inequalities, how we can represent this information visually using these number lines, and especially with this last example, how we can represent multiple bits of information and how that would look on this particular number line. But that brings us to the end of this video. In the next one, we're going to look more at solving these types of inequalities and some different things we need to be careful of when we do so. Thank you so much for watching though, and I'll see you in the next video.